Welcome. Again, my name is Jennifer Cedillo, and this is the last lecture that I'll be giving to you. This is data entry, record keeping, data analysis, and statistics. Before viewing this video, please read chapters 3 and 12 in the Standards of Brewing text. After viewing the video, please review the exam review sheet that I provided for you in the modules. Again, please email me with any questions you may have, and feel free to post on the discussion board under Module 9. In the previous lecture, you saw that data entry, analysis, and communication is an important part of your quality control program. Data entry is the process that you will use for capturing data. There are database programs such as Microsoft Access that can be used to manage your data entry. You also will want to make sure that you have proper analytic techniques to analyze the data that you're collecting, and these will can include simple statistics and control charting, which I will talk to you about. And then communication, this is from the previous lecture, a standard operating procedure for product release, disposal, or recall is important in your quality management program. So when talking about data collection, what data should you collect? Basically, you should collect data that's important to any step in your process in your brewery. This can be qualitative or quantitative data. Qualitative data would be, an example would be the sensory aspects of beer. Does your beer have high amounts of esters, or is it dry, or is it have a thin mouthfeel? These are all qualitative aspects that you can monitor to make sure that your beer constantly has the same flavor profile. Quantitative would be anything that has a numerical value. So measuring the gravity, beginning and ending gravity, these would be quantitative values that you should be collecting. Something that's qualitative that you could collect would be simple: is the beer fermenting by day 1, or within 24 hours, or within 48 hours? Yes or no? This would be another example of qualitative data that you can collect to monitor your process over time. And so why do you want to collect this data? To repeat processes precisely, and to monitor your process to make sure that quality is achieved every time, and that your process is consistent over longer periods of time. So one thing that's important when looking at data and deciding whether your process is accurate or precise is the exact definitions of precision and accuracy. And so an example of precision versus accuracy would be looking at the starting gravity of beer. If the theoretical starting gravity of your recipe should be 14.1 Plato, and the brewer hits that number, 14.1 Plato, when brewing a batch of beer, this is considered accuracy. A brewer that brews the same recipe 2 more times, each time hits a starting gravity of 13.8, this is precision, because they've repeated this outcome more than once. It's a precise method, where accuracy refers to actually hitting the number that you want to hit. And so when thinking about which is more important, it really depends on your process and what your intended outcome is, whether you're striving for accuracy or precision. Obviously, both of them are extremely important. So when you're collecting data, how do you go about record keeping? The easiest way to do this, and the most simple, cost-effective way, is to track by hand. However, having a dedicated computer available to input the data is certainly more efficient and can help you in the long run. Microsoft Excel or an equivalent spreadsheet program that allows you to input formulas is very useful and very time-saving. Also, the use of a digital site to allow access anywhere and to multiple users can be extremely helpful if you have employees who are traveling, who are important to know the day-to-day process. Digital sites that you can use include Google Drive, Dropbox, or SharePoint. And so when thinking about record keeping and deciding whether to do it paper versus computer, obviously by hand allows the data to be recorded in the brew house in real time. Certainly a brewer will not stop brewing to go and enter in data into a computer, but he can enter it onto a sheet of paper while he's brewing, and the same with your cellarman. However, paper copies can be lost or destroyed very easily, and if that's your only copy, then you've lost that data forever. Also, when you're recording only by hand, while you may have a binder full of these sheets, only one person, the people who are in person in the brewery can actually physically see these sheets. So someone who is not in the brewery looking at that binder cannot know the data that you have. And then finally, when you're wanting to analyze this data, most of this data is not easy to analyze by hand. You certainly can do it, and if you're a mathematics major, you might have fun doing it. But it's certainly something that would be very time-consuming if you don't have a computer program that can do these formulas for you easily. So using a computer, if you decide to do that, you must have a computer dedicated and available for use at all times. It can't be a computer that's in a locked office that a brewer can't get to, because that will prevent him or her from entering data, and you might be not getting a complete picture of all the data. Also, extra time will be required of your employees to enter this data. So the brewer, if he's recording it by hand while he's brewing, then he would have to go in after he's done brewing and upload this data. So that's something to consider, is that it will take extra time. However, positives are that it does allow multiple users to access and see this data from anywhere. And it does allow for easier and more efficient analyses. In addition to using spreadsheets in Excel and then also digital drop sites, there are also management programs that can help you to achieve a good quality control program, including Microsoft Access. There's Freeware. This is a website where you can see a project-based management program. And then there are brewery-specific management programs, and one specifically is called Orchestrated Beer, which can do everything for you from from accounting to quality control to brewing recipes to production management. However, it's a very expensive software, and it's a monthly license. But you can, this is a link, and you can take a look at this management program and see if it's right for you. And so after you collect the data and you decide how to keep your records, then you need to decide how to analyze this data, because without analyzing data, it is pretty useless. And so what can statistical analyses do for you? They can inform you on whether a method is helping or hurting your process. They can look at trends over time to see if there's drift in your process. And they can help to identify issues early on. And finally, they can help you define whether your beers are within your limited specs. And so when you're analyzing data, how often should you be analyzing it? And that's really comes down to what data you're analyzing. Daily, you should be looking at your fermentation data. You should be looking at gravity, pH, cell counts. If you're not analyzing this on a daily basis, then within a week, if a beer doesn't ferment, on day 2 it stopped fermenting and you're not analyzing it daily, you might not find out to day 7. And so it sat there for 5 days without fermenting. So you can see that data like this should be analyzed daily if possible. If not, every other day is acceptable. Weekly, you should be looking at your yeast. So every time you're harvesting and repitching yeast, you should be looking at that yeast. You should be looking for contamination, viability, cell counts, all of that. So that's data that should be analyzed on a weekly basis. And then you have data that should be analyzed monthly. So tracking the starting and ending gravity of beers for drift in your numbers. It could indicate changes in your system when you're brewing. Tracking fermentation in number of days of the beers with repitched yeast. So this is kind of from generation to generation. Generation 2 fermented out this beer in 5 days, where Generation 3 fermented out this beer in 7 days. This is something that you can track over a month and see from generation to generation, and then determine really when your cutoff generation should be. Now, these are just examples. There are many other data analyses that you can do, and you'll have to decide how often you need to analyze that data. This is an example of the daily readings that we would take on a fermenter. So here's an IPA, and we're looking at gravity in Plato. The starting gravity was 15, and you can see that by day 4, it's down to around 5, and then by day 6, and certainly by day 7, it's reached ending terminal gravity. And so you can see this is a pretty normal curve for what the gravity in a beer should look like. And then the pH, you can't see it here because of the scale, but it does take a slight dip throughout the process as well. And so if you're recording this data and you can graph it, and we can look at multiple IPA batches to see if they all follow this same curve. And this can certainly help you determine how your yeast is performing over time. So when analyzing data, we can use simple statistics. And so the Standards of Brewing book gets into a lot of statistics, which I'm not going to get into. I'm just going to give you very basic statistics that I think that you can practically use. And so those would include the mean, mode, and median. So when we're looking at these 3 terms in statistics, typically the mean is what's used, and the mean refers to the average of the numbers. So average and mean are the same. And so here's an example to show you the difference between mean, mode, and median. There are 5 samples. You have readings of 10, 20, 30, 40, and 40. The mean would be the average of these numbers. So you add these numbers and divide by the number of samples. So it's 140 divided by 5, and you get 28. So that's the mean or the average. The mode is the most common number there. And so you can see the mode, we have 2 40s, therefore the most common is 40. If each number was different, we would not have a mode for this data set. The median is the number in the middle of the set. And so in this case, the number that's in the middle of the set would be the 3rd number if we're putting them in order, and that 3rd number is 30. So you can see quite a few times the mean and the median can be very close. So the median may have some significance, where a mode really doesn't really have a lot of significance when analyzing data. And certainly the mean is the most used statistic. And so when using a mean, it should always be accompanied by a standard deviation. So here's an example. You want to compare 2 processes. You collect data using both methods. Process A results in an outcome of 25, 30, and 35. while process B results in 22, 25, and 28. The mean of process A, or the average, is 25. The mean of process B, or the average, is 30. By looking at these numbers alone, one might say that these numbers are different. 25 is different than 30. However, is there a true difference between these two processes? And to look at that further, you need to have standard deviation involved. So if we look at set A, the average is 30, and the standard deviation is plus or minus 5. And so both of these formulas are built into Excel, and so you can do the average and the standard deviation in Excel. It's noted for you here at the bottom of this slide, so you don't have to do it by hand. But for set A, the standard deviation is plus or minus 5. So this means that the actual range of the data is 25 to 35. For set B, the average is 25, and the standard deviation is plus or minus 3. So in this case, the range is actually 22 to 28. As you can see, these two ranges and these standard deviations will overlap. Because there is overlap, there is no significant difference between these two treatments. Therefore, in this example, the two sets are not different. So even though the means may appear different, taking into consideration standard deviation shows that there is actually no difference. And so either process A or process B could be used going forward. Another statistic that can be used, and again this can be done in Excel, is the student's t-test. And the student's t-test can be used in hypothesis testing. So in Excel, you type in the formula equals t-test, and then you will have to input 4 different numbers. Array 1, well 4 sets actually. So array 1 and array 2 are sets of numbers, and then tails is 1 number and type is 1 number. So in this example, the arrays, array 1 and array 2, refer to the data sets. So if we're looking like the previous example, data set A and data set B, you would have those in the 2 arrays. In the tails, you have the number of distribution tails. And so tails is the number that you would input here is either 1 or 2. Usually it's 2. It's only for specific cases that you would enter in a 1. So if you don't know, I would say just put in 2 for tails. And then finally, you have to put in the type of t-test. And so the type of t-test refers to the kind of t-test, and there are 3 different kinds of t-tests. And these are designated 1, 2, and 3. So for type 1, it's a t-test that assumes equal variance. For type 2, it's a t-test that assumes unequal variance. And for type 3, it's a paired t-test. So most of the time, you'd be looking at equal variance and you'd input 1. Unequal variance is a specific case, and I would recommend doing more research on that before deciding it's unequal. And then finally, paired. Paired refers to a test that you're looking at a before and after sample. So the same samples before and after treatment, then you would use a paired. And so the output of this test will give you a number. It will give you a decimal point number, 0. ... If that output is less than or equal to 0.05, it means that the data sets, the 2 arrays that you entered, are significantly different. And so there is a difference between those. And then you can look and determine, by looking at the actual averages, which is the better set for what outcome you're looking for. If this number for the t-test is more than 0.05, it means that there is no difference between array 1 and array 2, and therefore the samples are the same. or the process is the same, and there's no significant difference. And so this is a good test when you're trying to determine if you should be using process A or process B to go further in your facility. The limitations to this test are that you can only compare two different sets of data. So you have array 1 and array 2. If you had a data set 3, you could not use the t-test. That would be another test called an ANOVA that you would need to use. Also, the limitation on this is that it assumes normal distribution. And this is something that's slightly more complex statistical analyses to whether you can assume normal distribution of your data or not. And I'm going to talk about in the next example histograms. And if you can make a histogram of your data and show that they're normally distributed, then this could help you ensure that using the t-test is the right method.